Hi everyone, my name is Khalilullah Siddiqui and I would like to discuss about graph algorithms, topological sorting and tree, minimum spanning trees. And I'm gonna discuss about this into 11 slides. So we start with the definition part. So in definition, we have topological sort, an ordering of vertices in a directed acyclic cyclic graph, which is known as DAG, where for every directed edge UV vertex U comes before V. Minimum spanning tree, which is known as MST, a spanning tree of an undirected weighted graph that has the minimum possible total edge weight. Topological sort, DFS approach. DFS approach is known as depth first search for topological sort. Performs DFS on the graph order vertices based on their finishing time in descending order. Example for DAG with vertices 1, 2, 3, 4, 5 performs DFS starting from any vertex, record finishing times, order vertices based on finishing time. Topological sort in degree zero algorithm. In degree zero algorithm, identify vertices with zero in degree, remove them and add to the topological order. Repeat until all vertices are ordered. Example, start with vertices having no incoming edges, remove them and update in degrees of remaining vertices. Topological sort application example. Problem, arrange children in a line so no child can throw a rock at someone they hate. The solution for that might be like model the problem as a DAG, perform topological sort to ensure no directed edge goes from right to left. Question, why is it important to ensure no directed edge goes from right to left? The answer for this will be to prevent a child from being behind someone they hate. Minimum spanning tree, which is also known as MST. The definition for that is tree defines as a connected graph with no cycles. Spanning tree defines as a subset of the graph that connects all vertices with the minimum number of edges. Minimum spanning tree defines the spanning tree with the minimum total edge weight. Prim's algorithm MST. Prim's algorithm starts from an arbitrary vertex at the smallest edge connecting the tree to a non-tree vertex. Repeat until all vertices are included. Example, start with vertex A at the smallest edge connected to A, then repeat. Prim's algorithm correctness proof. Proof by contradiction. Assume Prim's algorithm is incorrect so that replacing an edge in the assumed MST with a smaller edge found by Prim's algorithm results in a lighter tree. Contradicts the assumption of the MST proving Prim's algorithm is incorrect. Is correct. Question, why does Prim's algorithm always choose the smaller edge to ensure? The answer is to ensure minimum possible weight is added at each step. Kruskal's algorithm for MST. Kruskal's algorithm sort all edges by weight at the smallest edge that does not form a cycle. Repeat until the MST is formed. Example, sort edges A to B is 1, B to C is 2, C to D is 3. This is how it edges. So Kruskal's algorithm example. So here are some examples that Kruskal gave. Given a graph with edges and weights, step-by-step addition of edges in increasing order of weight, ensure no cycles are formed. The question for that might be like people might have some questions about that. How does Kruskal's algorithm ensure no cycles are formed? So the answer is by checking for cycles before adding an edge using disjoint set data structure. MST applications. Applications, we have network design, clustering. In network design, we have cable, telephone, and electrical networks. Connect all nodes with minimal cost. Clustering, we have data clustering by deleting largest edges in MST, natural clusters form. The question might be, the question everyone might have is Why is the MSC useful in network design? It is used to minimize the cost of connecting all nodes. Also, like as you were discussing about the topological sorting, so topological sorting is an ordering of vertices in a directed acyclic graph such that every directed edge u to v vertex u comes before vertex v. It is used in scenarios where you use to perform tasks in a sequence respecting dependencies such as force or build system algorithm. So we have like Kruskal's and the Prim's algorithm. In Kruskal's algorithm, we have Kruskal's algorithm builds the MSP by considering all edges and adding them one by one, provided they do not form a cycle until the vertices are included in the MSP. Initialization sort all edges in non-decreasing order or their weight. Use a union find data structures to keep track on connected components. Like he, Crystal's algorithm, he gave an example that all the vertices are included in the MSC, which has initialization, main loop, and it has some examples for like I just explained about the initialization. Now we can go with the main loop. Main loop has pick the smallest edge, check if it forms a cycle with the spanning tree formed so far using the union find data structure. If it does not form a cycle, include it in the MSC. Repeat until they are one edges in the MSC where V is the number of the vertices. Example, consider a graph with vertices A, B, C, D, E and weighted edges A to B1, B2, like A to AB1, AC3, BC1, BD4, CD2, CE5, DE3. Uh, then like we have comparison between sorry, I'm really sorry. I need to the Prim's algorithm. When Prim's algorithm like start with a vertex, Prim's algorithm, he explains that he starts with a vertex and keep adding the smallest edge that connects a vertex in the tree to a vertex outside the tree. Use the priority queue to efficiently get the next smallest edge. Continue until all the vertices are included in the tree. Applications, network design, example designing least cost networking infrastructure, approximately algorithm for NP had no problems like the traveling salesman problem, cluster analyzing in data mining. Comparison and use cases between both of them. The topological sorting is used exclusively in DAGs where task has dependencies that need to be resolved in order. Minimum spanning trees are used in undirected graphs and focus on connecting all nodes with the minimum total edge weight useful in network design and optimization. These algorithms solve different types of problems and understanding when understanding when and how to apply them is a key in graph theory and practical application. So the depth first search DFS based algorithm performs DFS on the graph on returning from the DFS call add the node to the front of a list or push it onto a stack. The reverse of the list or the stack content will give the topological order. For MS in minimum spanning tree MST, a minimum spanning tree of a graph is a subset of the edges that connects all vertices together without any cycles and with the minimum possible total edge width. So in like Prim's algorithm, we already uh, learned that Prim's algorithm builds the MST incrementally, starting from a single vertex and adding edges one by one until the vertices are included in the MST. Whereas in Kruskal's algorithm builds the MST by considering all edges and adding them one by one, provided they do not form a cycle until all vertices are included in the MST. So at the last, I would like to have like compare both of them. Like Prim's algorithm is efficient for dense graphs and is easier to implement with a priority queues, whereas the Kruskal's algorithm is efficient for paired graphs and can be easier to implement if the graph is already sorted or if sorting edges is manageable. Thank you so much.